Question 2, Part A. Complete the table 2.1. Use the C for covalent bond, I for ionic, M for metallic, G for giant, S for simple. Okay, so for bonding, sodium chloride ionic, aluminum chloride ionic. Okay, so please remember, for the latest textbook that endorsed by the Cambridge, nowadays for AlCl3, the bonding is ionic. But the Al2Cl6 is covalent. Bonding is covalent and the structure is simple molecular for Al2Cl6. But for AlCl3, the bonding is ionic bonding and is giant ionic structure. So please understand and know the difference between these two. Okay, this is in the textbook. And the latest, this year mark scheme also, okay, is given this answer. Okay, so for this SiCl4, so bonding is covalent bond, then it's a simple molecular. PCl5 is a simple molecular. Means one molecule is just SiCl4, PCl5, okay, and so on. Okay, oxidation state of the period 3 elements. Period 3 elements is the sodium, aluminum, silicon, phosphorus, and sulfur. Okay, so this one is because chlorine is -1, so sodium is +1. Okay, then the aluminum is +3, silicon is +5, +4, phosphorus is +5. Okay, PCl3, the phosphorus is +3. Okay, and this sulfur is +2, right? Part B, write equations for the reactions of sodium chloride and PCl5 with water. Include the state symbol. Sodium chloride, you just put NaCl solid, okay, with aqueous, form these two ions in aqueous, sodium ion and chloride. Okay, PCl5 with water. PCl5 is a solid, water liquid, form phosphoric 5 acid, aqueous, and HCl gas. It's supposed to be gas, so I wonder why the answer is aqueous. Supposed to be gas. And you balance it, right? You get this equation. Okay, part C. Just complete this Al2Cl6 drawing, right? So from this AlCl3 to form this Al2Cl6. Okay, so you just need to make sure the dative bond is there, okay, between the Al and the chlorine, and this one also Al with chlorine, and you complete all the valence electrons of the chlorine and the aluminum, right? Something like this. Okay, part 2. State the effects of an increase in temperature on equilibrium mixture in equation 1. So equation 1 is this. So it's exo. When temperature increases, so this equilibrium will try to decrease it. Because forward is exo, is released energy, so it's not going to go forward, not going to shift to right. So it's going to shift to left. Because shift to left is endo, then it will absorb the heat, right? So that's why equilibrium will shift to left, because the forward reaction is exo. Okay, part D. 3.3 gram of sample of period 3 chloride is heated to 500 Kelvin, and the gas volume is 250 cm3. Pressure is 323 kilopascal. Now try to get the molar mass, okay, of this period 3 chloride. Okay, so this one is very easy. You just need to use a combined gas law. PV equal to nRT, so N is equal to M over MR. So find the MR. MR is equal to MRT over PV. Substitute all the values there. Okay, 3.3 gram, 8.31 times 500 Kelvin. Okay, this one you must change to Pascal. and this one must change to meter cube. So from cm cube to meter cube, need to times 10 power negative 6. Okay, after you calculate, you should get 169.8. Okay, so if 165.8, then you should know that is silicon tetrachloride. Okay, part E1. Excess chloride is added to 1 cm cube of bromine. Describe what is observed. Explain your answer. From here we know that when down the group, the oxidizing ability of the halogen decreases. Means the bromine is not really able to oxidize the chloride. So means chlorine will not form because bromine cannot oxidize chloride because it's lower in the group. So therefore we know that the bromine means the orange color still remains the same because bromine not able to oxidize the chloride. Okay, so now we have the SCl2, which is a liquid, and SbR2 is a gas. From the states we know that the intermolecular force for this SCl2 is much greater than the SbR2. So therefore you need to relate to either size or the dipole or the polarity. So in this case you must relate to the polarity. So how polar is the molecule or how polar is the bonding? Okay, because the polar is more bonding means the whole molecule is the dipole moment is greater, so it's more polar. So we know that SCl, okay, the bonding is more polar and the molecule is therefore more polar, okay, because the dipole moments is greater. Okay, so we know that SCl2 has a greater PD forces because it's a polar molecule, so it must have permanent dipole forces. Okay, so this PD force in SCl2 are stronger than the SbR2. Okay, why? Because the covalent bond in SCl2 is more polar than SbR2. So eventually it will make the molecules it has more dipole moment, stronger PD forces. Okay, part F1. Okay, so this one just to label the bonding, draw the label diagram to show bonding in bismuth metal. So you just need to put at least 4 particles, okay, and must put the charge positive there, must label the cation, or you just say bismuth ion. Okay, then you have to label the negative charge, okay, which is the electron. So this one, all these electrons, delocalized electron, right? Okay, for part 2, bismuth react with chlorine to form BiCl3. So BiCl3 is a solid at room temperature. It melts when heat gently, means low melting point, and reacts vigorously with water, means it can undergo hydrolysis. So from here we know that because it can melt when heat gently, so we know that it must be a simple molecular structure. Okay, because low melting point. And it must have covalent bond because it can hydrolyze easily. Okay, that's all for this question. Thank you.